Hello everyone, I hope you fine and safe. This is my first video on the oil analysis part 1, which is about loop testing. For oil analysis, I couldn't find many videos on the YouTube explaining oil analysis. So there is I think about 7 or 8 parts I'm going to publish in the oil analysis. So we'll take it slowly, step by step. There might be more videos in the future, but it would be nice to watch these videos. The first video, I'm going to talk about the loop testing, the different type of loop testing, maybe about like 10 or 9 types of loop testing, and we will go slowly one by one. I will be more focusing on what's the testing types, why we're using them, how to read the oil analysis report, what's the best practice to collect the oil sample, what's the testing done to the greasing, what's the best practice to collect a grease sample, how you grease a bearing, what's the different type of oil analysis testing for turbines, and what's the difference between them and the normal oil sample, how to do selection for oil samples, sorry, for oil type, what's the difference oil grades. This all what we're going to talk about and take them one by one. Today I'm just going to talk about the loop testing, different types for the basic oil sample loop testing. In addition, I'm going to talk about how to read the oil analysis report. As a condition monitoring engineer, you don't need to be very specialized in all the techniques and technologies. If your main scope is vibration analysis, you at least need to understand and know how to read the oil analysis report, how to integrate this oil analysis report with your vibration report to help you to do an analysis for like a gearbox or a pump or so. So let's start. As you know, my name is Salah Atiyah. I'm a condition monitoring and reliability specialist. I'm Cat4 vibration analyst, and also I'm machinery lubricant analyst level 2. Oil analysis and machinery lubrication. What's the tribology? It is the study of friction, wear, and lubrication science. The friction is the surface resistance to relative motion, and it could be like sliding or rolling friction. Why lubrication? Because it's reduced friction, reduce heat, reduce doing damping, and reduce the vibration, reduce wear, lowering the temperature, maintain the cleanliness, and of course the power transmission. What's the different lubrication regimes? You have the full film lubrication. This is a complete separation between the two different layers. And there is mixed lubrication, which is incomplete and partially separation, or boundary lubrication, which is surface only separated by molecules. The lubrication loop testing, we'll go directly. There is the first test is called flash and fire point test. This test is a flash point is represent the temperature at which the vapor over the liquid will start to ignite, and this will be under the test condition, and this is for the flash point. Also, there is another test called the fire point, which is always have which is always higher than the flash point by 15 to 20 degrees. Why are we using this flash and fire point? This will come, like I will explain every test on a separate video. We'll go them one by one. Just you need to know what's the test name, what you do with this test. The other one, which is the kinematic viscosity test. This test is done to determine the oil viscosity at two different temperatures, the 40 Celsius and 100 Celsius. Viscosity is the measure of oil resistance to flow. The flow is limited through a capillary tube. Then is timed through a capillary tube. Then that time multiplied by the tube factor, and that is the result we got from the lab. And when you send the oil sample, what you got as a viscosity in the oil sample report or the oil analysis report is the kinematic viscosity. And it's reported in centistoks or millimeters square per second. The sources of high viscosity, like you can see, like the contamination, the oxidation, degradation, leak in gasket, external oil drain, a high operation temperature, improper oil grade, glycol colon contamination. We will talk about all the contamination types in a separate video. The results, it's increased the operating cost, restrict oil filters, oil filter bypass, and sludge. The source of like low viscosity will be additive shear, fuel dilution, improper oil grades, and it can result in poor lubrication, engine overheat, and metal-to-metal contact. And the solution for this is to check the correct oil grade and check operating temperature, oil filter check, check the leaking in the injectors. This if like, for example, for diesel engines. The dynamic viscosity, this is different from the kinematic viscosity. As we said, the kinematic viscosity is the value we got on the oil analysis report. Dynamic absolute viscosity is used in engineering calculation and not represent on the oil analysis report. The foaming characteristic, foaming test is done to measure the amount of foam which can be formed over the oil sample under the test condition. Foam source are like cavitation, overflow, increase in oxidation. And silicon is the most common anti-foam. The test is done by aeration to oil sample for certain time and measure the amount of formed foam. I'm trying to not go in deep in details. Like I'm trying to give very simple explanation what this test means. Because you doing vibration analysis, this is your main scope of work, and then you got oil analysis report. You need to understand the meaning of all these parameters in the oil analysis report and know how it would be useful and how you can integrate this information to your vibration analysis report so you can give a good recommendation. It will be very good or very powerful tool to assist and help and support you in your last recommendation. The demulsification number. The test is done to measure the number of seconds for water to separate from the oil under the test condition. It should not take more than 300 seconds for water to separate from the oil. The TAN, or the total acid number, this test is a measure of the amount of potassium hydroxide in milligram, which is required to neutralize 1 milligram of oil sample. We usually use the detergents to neutralize the acid. And increase of TAN is increase of oxidation rate. Oil degradation and oil thickening and oil additive depletion. And that number increase as oil aged. When the oil more old, then the TAN number will be higher. The solution is to drain the oil, confirm the oil type, check for overheating. It's very important that you monitor the total acid number. The TBN, or the total base number, that number represents the amount of alkaline additive required to neutralize the acids in the oil. Low BN number is a result of overheating or higher sulfur or improper oil type, and solution by change oil type. Verify the oil type. BN decrease as oil aged. It's different from the TAN number. Like the TAN number is increased when the oil is aged. The BN number is decreased when the oil is aged. The BQ index, or particle quantifier index, the particle quantifier index is an arbitrary number from 1 to like 10,000, represent the mass of iron on the oil sample. It is important as it measures the quantity of wear and distribution of iron particles on the oil sample. FTIR, or Fourier transform in infrared, this test is done to identify the chemical elements on the oil sample, which allow us to monitor the change in additives and the oil deterioration. The particle count, or oil cleanliness, ISO 4406, this is a very famous test. The oil cleanliness laser beam going through thin section of flowing oil. An image of oil particle is formed on a photo detector. Number of particles is measured to be in 3 groups: more than 4 microns, more than 6 microns, and more than 14 microns. The isograde test is to represent each number of particles more than certain micron, and the order of this number should increase. I'm going to talk about this. I will make a separate video about only the particle count and oil cleanliness, how to read them, and how to understand them. The elemental analysis is the measure of additives and identify oil elements like calcium, magnesium, zinc, and so on, and see the amount of contamination in your oil. And this happened by ICB, inductive coupled plasma, and it worked by energy from ICB, makes like the outer electron move to the higher level of energy, and every element have unique electrons distribution, and this is the way you can identify which element is appear on your oil sample. That's all for today. It was a quick video about the different types of the oil testing. There will be much more better videos in the oil analysis, but we have to talk about this on the start, and then while we're going further, more information and more things will be explained to all of us. Thanks for watching. Please like, subscribe, and share, and again, stay safe.